Welcome to a lesson on variables and variable expressions. The goals of this video are to define a variable expression, and then write and evaluate variable expressions. A variable is a letter that represents an unknown quantity. For example, if I ask you how many hours you will study tomorrow, this will be an unknown quantity, so we get assigned the variable x to equal the number of hours you will study tomorrow. And in this case, there would be some restrictions on the possible values of x because we know there are only 24 hours in one day. So the value of x would have to be greater than or equal to 0 and less than or equal to 24 hours. Another example might be if your car breaks down and I ask you how much you will pay to have your car repaired. The cost of the repair would be an unknown quantity until the mechanic calls you and notifies you. So we could let the variable c equal the cost of the car repair. And in this case, we know the cost would have to be greater than or equal to $0. It could be equal to 0 if the repair was under warranty, and there probably is also some maximum value for c based upon the type of the car, but we'll go ahead and leave the restriction on the variable c as c is greater than or equal to $0. Now let's talk about a variable expression. A variable expression consists of variables, constants, numbers, and operations like addition, subtraction, multiplication, and division. So here are three examples of mathematical expressions. The first expression is 2x minus 5. Remember, 2x means 2 times x. Next we have 2 times 4a plus 10b. And the last expression is m divided by 4 divided by 6n. If we knew the values of these variables, we could then evaluate these expressions, which we'll do shortly. One thing we should be aware of is the difference between an expression and an equation. The main thing to notice about these on the right is that each of them has an equal sign, and therefore they are equations. If we compare this first expression to this first equation, for the expression, we can evaluate this for any given value of x. However, if we have an equation like 2x minus 5 equals 10, there's only one value of x that would make this equation true. The main thing to remember is expressions don't have equal signs and equations do. Now let's talk about writing variable expressions. Let's say a group of you and your friends want to go to the movies, and it costs $9 per adult and $5 per child to go to the movies. What would be the variable expression for the cost of a group to attend the movies? Well, currently there are two unknown quantities. We don't know how many adults will be attending, and we don't know how many children will be attending. So if we let x equal the number of adults attending, and y equal the number of children attending, the variable expression to represent the total cost for the group to attend the movie would be $9 times x plus $5 times y. Again, x represents the number of adults attending, and each adult will have to pay $9, and y represents the number of children attending, and every child will have to pay $5 to attend. Another example might be if you need to rent a car, and it costs $3 per day to rent the car, plus 10 cents per mile. If we want to write a variable expression for the total rental cost, again we have two unknowns in this situation. We don't know how many days the car will be rented, and we don't know how many miles the car will be driven. So we could let d equal the number of days, and let m equal the number of miles driven. So the total cost of renting the car would be $30 times d plus 10 cents times m. Now a lot of times you'll see variable expressions where they leave the units off. Notice on these two examples I did include the units or dollars in each case, but sometimes you won't see that in some textbooks. Let's go ahead and finish by practice evaluating variable expressions. So for this first example, we want to evaluate 5x plus 7 when x is equal to 6. The first thing to remember is that 5x means 5 times x plus 7. So if we're given that x equals 6, we're going to substitute or replace x with the value of 6. So we'll have 5 times 6 plus 7. We do have to remember to evaluate this, we have to follow the order of operations. So we'll multiply first. 5 times 6 would be 30. So 30 plus 7. So the expression is equal to 37 when x is equal to 6. Let's go ahead and try another one. Here we want to evaluate 4m minus 3n when m equals 9 and n equals 7. So this means 4 times m minus 3 times n. So we'll substitute 9 for m and 7 for n. So we'll have 4 times 9 minus 3 times 7. So we'll first multiply. So we'll have 36 minus 21. Well, 36 minus 21 is equal to 15. So 4m minus 3n is equal to 15 when m is 9 and n is 7. Let's try two more of these. Here we want to evaluate p squared minus 3q plus 7 when p equals 11 and q equals 8. So we'll substitute 11 for p and 8 for q. So we'll have 11 squared minus 3 times 8 plus 7. So we'll first evaluate the exponents. 11 squared equals 121. Next we will multiply. So 121 minus 3 times 8 is 24 plus 7. And now we'll add and subtract from left to right. So we'll have 121 minus 24, that's 97, plus 7 equals 104. In our last example, we have 36 divided by d plus 7e minus 9f when d equals 9, e equals 3, and f equals 1. So again, we'll substitute 9 for d, 3 for e, and 1 for f. So we're going to have 36 divided by 9 plus 7 times 3 minus 9 times 1. So now we'll multiply and divide from left to right. So 36 divided by 9 is equal to 4 plus 7 times 3 is 21 minus 9 times 1 is 9. So we have 4 plus 21, that's 25 minus 9 equals 16. And that's going to do it for this video. I hope you found this helpful.